Hello everyone, welcome to this segment routing basic to advanced TI-LFA series. This is our third video in this series. So part 1 talked about LFA, loop free alternate. Then part 2 talked about remote loop free alternate. And then these two videos also talked about what were some of the shortcomings that has actually led to the development of TI-LFA. So in this part 3, we will be talking about TI-LFA. So with that, if you recall on the conclusion part of remote LFA, what I said that thou RLFA improved the coverage what LFA has provided to us, but it still lacked that optimality aspects. What does that mean? I will give you a reminder in this, but I highly encourage if you haven't watched the part 1 and part 2, go and watch those and then come back to this video. And you recall what was the second problem with RLFA, or I can add LFA here as well, that no 100% coverage guarantee. With some optimal design, LFA plus RLFA can provide up to 99% of the coverage, but still that 1% was lacking. And to have that, TI-LFA was proposed. We will also see that why this 100% coverage was not possible with RLFA or TI-LFA. How come TI-LFA had provided that 100% coverage? Right. So with that, let's just look at the introduction part of topology independent loop free alternate. This is a concept in segment routing, and you need to have segment routing enabled. So TI-LFA. First of all, as I was saying, LFA, RLFA provide 99% of the coverage. TI-LFA provide 100% coverage with 50 millisecond for link and node protection. What does that mean? That means with the introduction of TI-LFA, along with SR, of course, the research on loop-free alternate can be marked as complete because now we have 100% coverage. Why 100% coverage? As I was saying, I will come to that point. But not only 100% coverage. TI-LFA also provide the protection against any transit congestion or suboptimal routing. If you recall, I just showed you in the conclusion part that RLFA or LFA for that matter had the issue of this suboptimal routing. But TI-LFA provide this optimal routing along with the 100% coverage. Isn't it that's a cherry on the cake? But wait, I'm not done yet. It is very simple to operate and understand as well. If you stay till the end of this video, I will use very simple analogy as I normally do. After watching those, you will not forget the TI-LFA part. And another part to this simplicity is that it takes only two commands to configure the TI-LFA. I will show that this protect your LDP and the IP traffic. So now for this part, as I was saying that it is easy to understand, let's just take one simple analogy. In fact, the same analogy that we have taken in our LFA and RLFA part. And now let's introduce some more glitches into that where our RLFA fails. So then we need to go with TI-LFA. So this was the analogy that I was showing you for quite some time now in part 1, part 2, and it was actually a real story that I can tell you now that me and my family were on a road trip, and that's where we saw that there was this road was blocked because of the excessive rain that was happening, and the traffic cop there has asked us to take this alternate path, which eventually met into this same highway so that we can bypass this. So this is something we have talked in our part 1. Then in part 2 we have introduced this another stretch here which was connected, and a very helpful gentleman told me that don't take this path, instead you take this path 2, and then eventually you will be able to bypass this problematic stretch. So I followed these advices so far and just continued my journey. But then, as I was going on this road, at some point I saw that there was rain again started, and water started accumulating on the road. And here I was getting slow down, and slow down. And then suddenly I saw that one guy was even standing here as well for our help, and he told that you can take this road. Now I can see that there is water that is getting accumulated on the road, but he said, no, you can still take this road. I was a bit skeptical, but wanted to follow his advice because there was no other way. And then he came closer to the car and said, don't worry, my son, you take this path and it will all be fine. When he said this with so much of confidence, that's where I realized that, okay, let me go and it should be fine. And when I was going by this path, I realized that even the water was there, but it was not that much. I was able to drive through this, and it got on this main road and continued my journey. Now, what was this part that has to do with TI-LFA? When I came here, I saw that there is some water that is getting accumulated. There is some problem, which I even saw on the main road, but there they had covered it well. But here, because it was local road, I could see that the water is coming. But this guy has given me that assurance that you go and take this path, it will be all fine. For now, you just remember this part, that even though there was problem that I could see, but still somebody told me to forcefully that you take this path, it will be fine. And eventually everything went well. I was able to continue with my journey. So you just remember this part, and I will connect this dot with TI-LFA. So with that part in mind, right, let's just revisit this topology. You may recall that we had seen this topology in our part 2 as well, and we had seen how remote LFA work just fine in this case. All I need to do is just tunnel the traffic to somehow to the node 7, of course via 6 when this link fail, and 7 will naturally, and I repeat, 7 will naturally send that traffic to node 5, which is my ultimate destination. But RLFA work just fine with this till we twist this a bit. What is that twist? That twist is that rain that I had seen when I was on that path, and that gentleman came and told that you take this path. How can we relate that to the networking? Let's say that I or somehow the cost on this path is more. Now, even if the traffic come to 7, the shortest path from 7 also via 6 to 3 and then 5, right? If you recall, these LFAs, whatever it is, loop free alternate, remote loop free alternate, or even TI-LFAs, you calculate when this link is up. Remember that insurance analogy? When you need the insurance and if you are taking that, then it is too late. You need to plan it, take in advance so that you can use the insurance when you need it. Same way, you need to calculate the backup path, the loop free alternate backup path when the link that you are trying to protect, that means this link is up, right? And when this link is up and with this higher metric, 7 will send the traffic back to 2, 3 and then 5. That means remote LFA will cause issues in this. But then if that helpful person come here and say 7, that even though this metric is high, you send the traffic via this path only, then I have a perfect backup path. And that is what the TI-LFA does. To give you a hint here, for the advanced users, I am talking about adjacency set here. But more on this, I will come in the upcoming few minutes. Right? So now let's just come back to our topic, the TI-LFA. So TI-LFA, as I was saying, provides the 100% coverage, and it also uses the post convergence path. Remember, LFA, remote LFA, they will just do some workaround. But TI-LFA will have the path that will be used after IGP has converged following the failure that we are trying to protect. And operators, when they plan their bandwidth capacity, they plan it keeping their primary link, and when the primary link fail, what is my secondary link? So they take that into consideration. So your post convergence path, right, which is your secondary path, will have that much capacity thanks to the planning that these operators do to handle that failure case. And TI-LFA, because it calculates that post convergence path, even to mitigate that failure that is there, so that when the IGP is calculating the path, you already have this loop free alternate path which will be same as your post convergence path, right? So now I have raised this question initially as well, why we have never used it before SR. Because, now listen to me very carefully here, because giving 100% coverage was not possible without explicit routing. If I go back to that analogy, if that gentleman on that day would have not been there, I would have come back thinking that there may be more water on that road and I may get stuck. But he had given me that assurance that you go. He explicitly told me that you go. In the previous example, where the higher metric was used, We can say, or we can see by looking at the topology, that if 7 send the traffic to 3, if I go back, if 7 send the traffic to 3, even though there is this high metric, it will reach 5. That means if I use some sort of explicit routing, if I tell 7 explicitly that look, this traffic is destined for 5, send it towards 3 for LFAs, then I will be able to find a loop free alternate path. So why it was not used before SR? Because of this. 100% coverage was not possible without explicit routing. And then, thanks to SR, thanks to segment routing, we can now use this post convergence path. So TI-LFA basically uses this loop-free post convergence path by encoding it as a list of segments. So let's just look this with some more example. So this was the topology that I had shown you during LFA case. During loop free alternate, what we had seen that if we are trying to protect this link, 2 will ask its direct neighbor, which is a provider edge. The edge network may not be planned well in terms of capacity. So if this is my path, LFA, which is denoted by this blue line, will calculate this suboptimal path, whereas I can see that this path is there which traverse via the core devices. But here, if we implement the TI-LFA, that will have this path from 1 to 2 to 6 to 7 to 3, and from there it will go to 5. And when this link fails, as you can see, your IGP will also calculate the same path. How does basically the TI-LFA does this? TI-LFA eliminate that link that you are trying to protect from the SPF calculations. The concept of PQ space, PQ nodes is still applicable. I have explained that in our part 2. And here 2 need to pump the traffic to 7, and even if let's say we go with this higher metric, so it will have this adjacency segment. I will come to this with some more analogies. So protecting a destination which is node 5 on node 2 against this failure, as we can see, the classic LFA calculate a suboptimal path, but TI-LFA calculate the correct path, which is your post convergence path as well. And if I talk about the same topology, how does TI-LFA help in this case? If we take this higher metric example, as I had shown earlier also, the traffic from 2 will be sent to 7 via 6, and it will use this adjacency SID. Let's say I'm just assuming that this is the label. So adjacency SID is what it will use to send the traffic in this direction towards 3. Once the traffic reaches to 3, it will go to 5. Now this is something that may sound confusing. So let's take a topology and then we will look at a packet walk as well. When the failure happens and how does TI-LFA triggered and how does the packet walk look like. So at a high level, let's just try to see how does the packet walk look like. I will try to draw on the same sheet. So initially, let's say the SR is enabled in this and the packet is taking this path. So the packet, let's say this is my IP payload, and on top of that I will put this label. By looking at the range, you can say that this is a SR label. So this is what I will do. Now with TI-LFA, what it will do, when this link failed, traffic has to be switched to this path immediately. So what it will do, it will push that label stack, which is by the way is already calculated. So it will have that 16005, and from here on it will push that label stack for the backup path. So it will do this 24002. Let's say this is my adjacency label, and then it will put this 16007 at the top label. So this packet 2 will send on this path. 6 will see that the top label is 16007 and 16007 is directly connected. So here the penultimate hop popping will happen. So the packet will go like this 24002 on this link towards 7, and then 7 will look at this label which this guy is only allocated for this link. So it will pop this label also, and here on this link the packet will go with just single label, right? And then from 3 it will be sent towards 5. So that's how, with this simple analogy, the TI-LFA help you to cover 100% topology coverage. There are some more terms in this that I will demystify in the next part of this video. So basically this is the lab topology in which I have 4 iOS XR based devices, and this lab is already running with OSPF as a IGP, and segment routing with MPLS is also enabled. What I will do is I will configure the TI-LFA, and we will basically check on this node for this prefix. So 1 and 3 are directly connected. So I will check the route for 10.1.1.3. So you will see that PHP, but the backup path, once I enable the TI-LFA, that's where the TI-LFA magic come into the picture, will take this route. And this node plays a key role that I will show you in the CLI as well. So you may take a picture of this, as this will be helpful when you will be seeing the lab CLI demonstration. So with that, let's get on to the CLI and enable TI-LFA. As per the topology that I had just shown you with 4 routers, this is R1. So what we will do here is we will enable the TI-LFA on all these 4 routers. But before that, let me just show you what we already have on these devices. So I'm running OSPF as an IGP, and I have already enabled the segment routing on these devices. And if I show you this MPLS forwarding table, we have the SR label allocated for the different loopback prefixes of these devices. And then let's just also check the routing table here, and if I just check the route for OSPF, as you can see that this is R1 and I have the route for 2, 3 and 4, which are the loopback addresses of other devices. Now we will enable this TI-LFA on all of these routers, and what it basically take is just 2 commands, as I was saying earlier. So we'll go to this OSPF and then we go to the area 0, and here we just say this fast reroute per prefix and fast reroute per prefix TI-LFA enable. That's it. That's the command that you need to enable the TI-LFA. I will go and commit this, and I will pause the video and will enable the same command on all the 4 devices. So this is my last router, where as you can see that I have enabled the TI-LFA for this area 0, and all you need is these 2 commands. Now let us proceed with the verification. And the first step that we will look is, we will look at our OSPF routing table, and if you see, there is this extra symbol that had come. That means this is a protected path. I do have the TI-LFA path for this one. Earlier, if you see, before enabling this, you don't see this here. So that is the first sign that you can look for when you are looking for the TI-LFA backup paths. In fact, you can also look here, show route, and as you can see, this is the symbol FRR backup path that you see in the routing table for the remote destinations. And if I now take a particular destination, and let's just look for some more details. So what I will do is, I will check the route for 10.1.1.3, which is R3, and as you can see that this is the direct link which is going, and it is protected, and my backup is via 10.2.1.2. This is the backup TI-LFA path, and the repair node in this case, it shows as 10.1.1.4, which is R4. There is this one more command that you can use, and here as you can see, I was looking the route for this one, and it says the backup path TI-LFA repair list, and this is the P node 10.1.1.4, which is my R4, and the label for that is 16004. If we check here, the CEF table shows CEF 10.1.1.3. That's the route I'm looking for, /32 detail. And here, as you can see, the first thing is, this is my primary path which goes directly, as R1 is directly connected to R3. So you see the imposed label is implicit null because the PHP happens by default. And then look here, this is my backup TI-LFA path, and here the repair node, the P node here is 10.1.1.4, and look here, the labels that get imposed are, first I need to take it to 4, and from there we will take it to 3, as I had shown in that topology diagram previously. So this is how at a high level this works. Of course, you can enable link protection, node protection, SRLG protections for this. But as this is a basic video, so we will take a pause here. I hope this was informative, and thank you so much for viewing.